Right, here's our video today. Thunder and lightning. You never see a picture of thunder, right? Because thunder is just sound, right? It's the sound of lightning. And lightning, as you're seeing in this picture, right? It's just cutting through the air and it's expanding the air very rapidly. And it's going to reach around 50,000 degrees Fahrenheit. That's 5 times hotter than the sun. You hear that a lot, 5 times hotter than the sun. The surface of the sun. Remember, the core of the sun is 27 million degrees. So lightning is nowhere near the core of the sun. In fact, it's nowhere near the corona, the atmosphere of the sun, which can get close to 2 million degrees. But anyway, in this video, we'll talk about why there's lightning and what makes that thunder sound. We'll talk about that as we listen to the rain. And by the way, if you have a fear of thunder, it's called brontophobia. I should write that down, brontophobia. It's not the fear of brontosauruses, those dinosaurs. Brontophobia, fear of thunder. Interesting name, brontophobia. Now, when you're seeing lightning, also, you know, a lot of people might say, "Well, lightning's not coming from the clouds; it's actually coming from the ground." Well, yes and no. We'll talk about that in the video too. Now, if you're looking at the lightning, right, we're talking about an enormous amount of heat, like we said, 50,000 degrees Fahrenheit. And so what it's doing is it's ripping across the atmosphere. And so, in our atmosphere, we have nitrogen, we have N2, two molecules of nitrogen, we have O2 and other molecules. And what they're doing is they're heating those molecules up and they're making them vibrate very quickly. And that vibration is going faster than sound. It's creating a sound wave. In fact, it's creating more than a sound wave. It's creating a shock wave. The air pressure is going to increase enormously because of the temperature. And so that sonic boom you're hearing is from the heating of the atmosphere. And we'll talk more about that. All right, we'll make a cloud. Try to make a cloud anyway. There's some lightning. All right, we'll make our cloud. A little fun little cloud. So, and basically, when we know the water cycle, we know that, and we'll use yellow. Why not? So, when water vapor, well, we just use blue. So, water, warm air rises. The warm liquid vapor is rising into the cloud, and so we have this liquid water that is condensing. It condenses, and inside the cloud already, they have these ice crystals. And the ice crystals and the liquid water that's condensing are bumping into each other. So you have these crystals, let's say, bumping into each other and causing static electricity. And you know this, when you walk on a rug, you're creating static electricity. I'm sure you've done a lot of experiments in the lab with static electricity. You're basically rubbing and you're moving electrons around. So what happens in the cloud is you get these negative electrons forming on the bottom of the cloud. There we go. And on the top of the cloud, we'll put a different color. You have these positive protons, right? Ions. Now, which is interesting, you think that because of they have different charges that different charges are attracted, you would think that the negative and the positive would be attracted to each other. In fact, they do not cross this boundary. And what's interesting is no one knows why. It's a big question. They're still researching. So we have these negative electrons, negative charge particles on the bottom of the cloud. And on the ground, use green on the ground, what's happening is you're getting a buildup of positive charges. And you can see what can happen next, right? And what's really happening here is the force that's happening here. It is causing the electrons in the ground to move deeper down. So the electrons are moving down. And so you're causing the ground to have a positive charge. Just think about something when you rub a balloon. You have a little balloon. Here's a little balloon. And you rub your head. There's your head. And you rub it. And what's happening is the electrons in your hair will move to the balloon. And the balloon will become negatively charged. And you will become positively charged. So if you just touch metal, you'll get that shock. Same thing happening here. And so what will happen is, the first thing will happen is the negative charge will come down the cloud, but you won't see this. This is the invisible part. And what happens is, once it's coming down, the positive charge will come up to greet it. It's like, hey, let's be friends. And that's what you see. You see that positive charge meeting the negative charge, and that's the lightning bolt you see. So in a sense, yes, the bolt itself is not coming from the ground or the cloud. It's the positive charge coming from the ground, and that's the part you see as lightning. And the thunder, remember, you gotta see the lightning before the thunder, because lightning, it's lightning. Thunder is just the noise that lightning would make. So when it's coming through, when it's making this bolt, it's gonna heat up the air. Heats up the air. As I talked about the temperatures already, it heats up the air, heats up the N2, the nitrogen, and the oxygen, O2, that we have. And it's going to increase the air pressure, and it's going to expand. These molecules are going to vibrate very quickly, and it's going to expand the air, causing a sonic boom. And a sonic boom is faster than the speed of sound. And so that's what's happening here. You're hearing that. Just think of a whip. If you take a whip and you whip across the air, you're moving air. You're causing a sonic wave also. If you move your hand, right, you're going to make a sound. It's a small sound. It's a very tiny sound compared to what lightning can do. Because lightning is not only moving so quickly, it also has that enormous amount of heat and air pressure. So you can imagine that sound it creates. All right, that's our video today.